If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level. So today we will be seeing the position of a point with respect to hyperbola and the position of a line also with respect to hyperbola. And along with that, the condition of tangency will also come. We will also see number of tangents that can be drawn to a hyperbola. Okay, then let's see this. Now if you start some articles about this one, so I am taking help of ellipse because it is exactly similar like ellipse, so I am not deriving each and every one. I am drawing the conclusion from ellipse, and that's why I have taken ellipse notes also, so that you can remember, you can find a resemblance between these two. So first one is the position of a point with respect to ellipse, same. The point is given, ellipse is given. So like the same way, if I derive, what will be this? Instead of this minus, there will be a plus. You can see, instead of this, it will be, you can see this one. This will be of this fashion. Because what will be this one? Instead of y, it will, in hyperbola it is minus. So instead of y, if you calculate, it will be x square by a square minus 1. Instead of 1 minus, it will be this minus this. X square by a square minus this. X square by a square minus this. So if you bring it this side, so it will be minus x square, then minus 1. So if you just reorientation this will be something of this fashion. Now everything just changes little bit because you are multiplying this one minus, so this get changed. Okay, so whichever is now giving what? So this, if I take this is region 1, these two are region 2. So region 1 I am saying that it is outside that hyperbola. Region 2 I am saying inside. Just reverse of this one. In case of here, region 1 was inside, region 2 was outside because it was inside the hyperbola. So everything remains same. It was earlier lesser than, equal to, or greater, but here it is changed because you have multiplied. So whatever lesser is coming, that will be became here greater. So that's the idea. So you can see if P is inside, it was, if it is less than, then it was inside. Now if it is less than, then it is at region 1. You can get this idea because I am multiplying minus, so everything is changed. You can think of in that way. So if it is less than, this is region 1, which is not inside this hyperbola. We say within the hyperbola means we say these two. That is within the hyperbola. This is not. So here it was less than was inside the ellipse. So little changes are there. Equal to means on the hyperbola, greater than means region 2. That is within the hyperbola, we will say, and that is without hyperbola means outside hyperbola, you can also speak. Now if you see the position of line, that is nothing but condition of tangency, like the same way we have derived. What will be difference? It will be only, instead of, because there will be a minus sign here, and that's why there will be a minus sign instead of, in place of, before b square. That's it, there is nothing else. So before a square it is minus 1. So if these two are equal, that becomes condition of tangency. In case of ellipse it was plus. So if it is greater than this one, if it is greater than this one means there will be multiple roots. D is equal to 0 means one root tangency. If D is greater than 0, that means two roots. Two roots means it will cut it at 2 points. That means it will be a second. And if it is less than, then it will not cut. That means it will pass as outside the hyperbola. It will not cut. Similarly here also you can include these 3 points. 2. So the equation will be, what will be the equation? I have not written. So the equation of tangents will be here. You please make it this note in the notes. So it will be y equal to mx plus minus a square m square minus b square. So this will be the equation of the tangent. You can remember if a slope is given to you, m. Now if you can again come to this one, number of tangents that can be drawn in the hyperbola from a point. Similar approach like the way we solved it. Similar approach if you do, at the end what you will get instead of this one, instead of y square minus b square, you will get y square plus b square. So I have written only that. A similar way like your hyperbola, like your ellipse, you will get it in hyperbola. Instead of this minus, you will get this plus. In general, we can draw two tangents, that we will see how. Because it is a quadratic, this quadratic means you can draw two tangents which can be real or imaginary. Now how many real, how many imaginary, that you will see. Now if you take minus a square by b square common, is this one. Now if d has to be greater than 0, because there is a minus sign, so this has to be negative. So because this has to be negative, now you can see that means P has to be region 1. What is negative? Negative means if it is negative, then it is in region 1. So if it is in region 1, then you will have D positive. That means then you will have two tangents. So if your point is in this region, so if you draw tangent from this region, any point from this region, you can draw two tangents from here. If it is equal to, then it is only one tangent. If it is less than, D less than, that means this is positive. This is positive, that you have seen region 2. So if you are in region 2, you cannot draw any tangent because you are inside the hyperbola, you cannot draw any tangent. So these conclusions, these derivations I am not doing because it is exactly same as ellipse. So I am drawing the conclusions from the ellipse. If you like the video, then press the like button and please give your valuable comments in the comment section.